Raz. Okay. Okay, I think we can start. Before we do that, can somebody let me know that I'm audible? Can you hear me? Okay, I think I'm heard, I'm not sure. Okay, in any case, we'll start now. Hello Alison, can you hear me properly? Yes, working, audio is perfect. Thank you very much. All right, so welcome to the first stream in English. The plan is for the stream to continue every Thursday at 8 p.m. or 6 p.m. or 8 in the morning, depending where you're watching. The idea for now is that we'll be running the streams in a 1-to-1 ratio when it comes to content until we specialize in any particular direction that would either grow organically or will be the result of the conversations that we'll have through the chats and otherwise. But the primary premise of the stream is to deal with all things data science, from basic data analysis and exploratory data analysis and discovery, all the way up until the elements of deep learning neural networks and further on. So I have a couple of shout-outs to make before we start. First and foremost, it's my dad's 60th birthday today, so happy birthday, Dad. Second of all, I would like to give a big shout-out to Alison, who is my first Patreon and supports me in this endeavor to continue with the streams, so thank you very much. And also a big shout out to people, friends and random people from different areas that gave me the feedback on my Polish stream to make it better. So I really, really do appreciate it, and I hope I can learn and become more efficient and better in terms of the coverage and the delivery of their streams further on. Okay, so today we're going to be dealing with a relatively basic set of challenges that come from, maybe I can show you, this GitHub Pandas Exercises. Or not. Hold on. Pandas, let me just check. Is this GitHub? Yep, that's the website. Okay, so you can see here we have different folders with different challenges that have specifically to do with the Pandas package within the Python language. Today I thought as a promotional / introductory video we could just deal with one challenge, and further on we'll be dealing with more and more as the time allows. But today I have something special planned in the sense that we'll be dealing with a lot of colors and how we can style the outputs of basic exploratory data analysis functions to make it slightly more informative and overall prettier. So that's the coverage for today. We'll be dealing with that in the environment of Jupyter Lab, and we're doing that for the two reasons. One is that it is a perfect tool in terms of the quick fire code to quickly look into data, make sure that you have everything you need before it goes into production, and perform basic descriptive and predictive analytics on the fly. But also the second reason is that it comes with the whole Node.js package, which basically means that we can have the stylistics of the entirety of HTML and CSS when it comes to graphical representations of data and text files in general. So these are the basic ideas behind today's stream. Feel free to interact on chat. If you have any questions, by all means do ask them. I'll be more than happy to answer them to the best of my ability. Okay, so without further ado, let's just jump into it. We'll just close this for now. Today's data that we'll be looking at is, maybe I'll just move it here so you can see. It's the, I believe it's the American chain of shops called Chipotle. We can actually check that. Chipotle, I'm not sure how you pronounce it. And it is to do with food. I think it's something that you can just have food delivered, something like this. It's I don't know this, I've never been or used this company, but I believe since they're there, might as well use them. Okay, so we can see the text is pretty boring here. We have some information regarding the order ID. We have, maybe I can make it slightly bigger. Order ID, the quantity, the names of items, the descriptions of choices, and the price. I believe the price is per item. But what is interesting to us specifically is that these separators are tab separated items. What that means for us, it gives us information on how we can read in the data and what to do about them. There are a couple of other interesting facts that we'll be looking into slightly later. So let's now try and move to importing the data. Okay, so what we'll do is import the necessary libraries. We won't go into detail on why we import it this way. What is important to us is that we have this little alias here, so that we can refer to it later as PD rather than the entire word of pandas, because we'll be potentially typing it in multiple times. Okay, so let me close that and we'll continue. So let's read in the data. We have the address here where the data is located, so let's just grab this address and assign it to a variable called URL, because that's what it is. Okay, and what do we do? They want us to call the variable cheapo, so that we'll do that. Cheapo, and we redeem the data using the method readCSV, because believe it or not, readCSV can read in URL information provided it's a tabular data. So URL, and we saw that the separator was a tab, and this is the symbol for the tab. And with any luck, we should have the data read in. So let's see if that's indeed true. We're supposed to look at the first 10 entries, so we'll do that. Okay, so we have the data correctly read in. So now, let me say a few words by means of introduction, what styling means and what Pandas has to offer when it comes to this particular feature or set of features. As you can see, this package, this class, this set of methods that is offered to us has a bit of functionality when it comes to styling and coloring the data in terms of the outputs that are interesting to us, both in terms of the graphics and also the information. So we'll try and color these things today. We'll try and have a look how we can implement this into our context. And from then on, we'll do our best to get some or derive some information from the data set based on these color features. All right, so let me just move this back. So this is what it is when it comes to the styles. I should mention one more thing. And the one more thing is when I search for limitations. There are a couple of limitations because it's a brand new framework to use, which basically means there is only a set of data types from the Pandas perspective that we can use to implement this package. First and foremost, this is only for data frames. We'll find some ways around it, but primarily this is to be used on data frames in their entirety. Otherwise, it may not work. The second stipulation is that the indices and the columns must be unique. So we can't have any duplicates, we can't have any repeated values because it won't work. And because it's such a style-heavy package, it is still suffering from low performance. And that's why it's only used on data frames, and it's only used for summary statistics, which is what kind of is our focus tonight. So it kind of serves us quite well. It cannot style anything else but the values. So what I mean by this, or what they mean by this, we can only stylize this bit here. Sorry, not even that. This bit here. Right here. We cannot style the columns, and we cannot style the indices, which is a shame, but it's not a big deal overall. Since it's a new project, I think it's quite worthwhile anyway. Okay, so we're going to fillet this head method today in terms of output of the top elements of the data set. What are we going to do? We're going to try to interact with the documentation as we implement various functions as method from it, because there's generally two approaches to interacting with the documentation. Some people prefer to read the doc strings first and then implement the code. Some people prefer to look at the code and when they get stuck, they look at the documentation. Some people interact with it on a regular basis. What I would like to recommend is find your own way and stick with it. What I personally believe is whatever works for you, and it doesn't mean that it's a bad or good method, it just works for you, whatever gets you there. Okay, so with that in mind, let's move on to the styling. Now, I want to discuss two methods today. The first one is the print method, and if we do the same look into the top of the data set with the print method, you can see that the formatting is kind of gone. You can see that it's just as plain of an output as it can be. You can see the separation sign that splits the data into two rows for a better overview, but it's very plain and very boring. Excuse me. So what we'll try to do is to make it slightly more interesting and make it slightly more informative, because it's very hard to read this, not only from the output perspective but also from the information derivation perspective. So we're going to delete that and look into the function called display. And display is a built-in method for the Jupyter Lab or Jupyter Notebook, whichever you prefer to use. And I strongly generally encourage to try to abuse and use the tools that you're using to the best of their ability. If we put a question mark beforehand, what we'll see, hold on. What we'll see is the doc strings of the method, and it gives us all the information that has to do with this method. If we do two question marks, what we'll have is the source code, and the source code is probably the best kind of information of how the method is implemented step by step, with all these ins and outs and quarks and arcs and all the other elements that you might potentially be interested in. And what is interesting to us is that we have the support for the all these elements here, from HTML through JSON through PNG, JPEG, SVG, and LaTeX. So we will make use of this functionality today to have the best kind of output possible. Okay, so if I just do display, and do the same Chico head 10, we'll get the same output as initially when we first typed in just this element here. What that means to us is that display is by definition built in as a method of printing text out to the console here. So as you can see, it looks exactly the same as the initial input that we did. All right, let's start stylizing this a little bit. And I'll show you again the differences. We'll be comparing and contrasting these two methods as we go along. By two methods, I mean the print method and the display method. So let's try and do the head. Again, 10 outputs as the tasks requires us to do. And what we'll do is we'll try to start using the styles, and we can highlight no values. And what we'll get, as you can see here, is just a generator function that is stored somewhere in the memory. We don't quite know where it is apart from the memory address. We don't see any output first and foremost. As you can see, the print method does not give us access to anything related to the formatting associated with HTML or CSS, which is a shame. So let's now try to use the display function. And as you can see now, the output is quite different. We can see now that the NaN values, which stands for not a number, which basically means empty value, is highlighted. We can choose and change the color No color as far as I remember. We can do green maybe? I'm not a specialist on colors, trust me. I just know, I recognize two, which is nice and not nice. But you can see we can stylize the colors and it shows us the output with the nuns highlighted, which is quite interesting. We're getting somewhere. We can also do the same thing if we search for, if we do the highlight maximum values function. You can see that the quantity in this particular set of observations of quantity of 5 and the order ID of, quantity of 2 and order ID of 5 is displayed here and highlighted, which is quite nice. Which, by the way, suggests to us that the item price is not treated as a number, partially because of this $sign, but also because there is no highlight here. So if we check, in fact, what is it? Item price dtype. It is indeed an object, not a number. So we'll need to handle that later on. Okie doke. Let's stylize it a little bit more. We'll try to focus on the one cell today, and I'll upload the completed notebook later to my GitLab, which is in the description of the video. Let me just check something real quick. There is still silence in the chat. Okay, we can continue then. All right. So now what we're going to do is stylize this even more, this particular output that we were looking at. I took the liberty of writing just pure JSON file or JSON code that will allow us to stylize it the way we want it, and I'll tell you how to tweak it later on as we go along. So what we'll do now, we'll still look at the first 10 entries as the task suggests us to do. Let me just run this so it looks nicer. And we're still using the style, and we can look at the was it table styles? Table styles? Yes. Okay. Styles. And now, I'm not going to ask you to watch me type in the code, so I only have this particular code prepared for you, so we don't have to lose time as you watch me code. And let me just go through it real quick. We have a particular selector, and this selector now is used to stylize our particular parts of the output. But I strongly encourage you to look into the selectors overall, as we will be using them later as we do the web scrapers programs that we'll use to find different texts on websites, and how we can go about this, and how we can drill around the HTML structures. And the selectors, especially CSS selectors, come as great help to us. So these little things, the TH, TD, TR, TR, and TR, are the HTML tags, and I will only briefly show you HTML tags, what they mean, and there's a whole bunch of them, so we won't go into what each of them means, but you can see there's a whole lot of them here for us to enjoy and use in our code. What we have is the TH. So what is it? TH. Not here. TH. Let me just quickly find it. TDTH. This particular tag has to do with headers, which basically in our context, do we not have the output? No. Just have it so I can have a reference. Which basically means this. These are our headers, usually row 1 in the dataset as the column names are suggested, which tell us about the variable types and variable names of the dataset. The second one if we look at here, again TD, has to do with generally digits, data cells, and similar things. So in our context, it's this here. So what is the output here? And we can drill into that even more by choosing the rows tag. Rows as in rose, not rose as in the flower. And you can see here, we've chosen our background, which is a hexadecimal color, and we'll deal with colors and why they're coded hexadecimally or RGB or CMYK or all the other coding elements. We'll look at two specifically today, the hexadecimal one and the ANSI colors coding in the print function later. The idea here is that we've chosen our background color that I could potentially show you, but you'll see it in the output anyway. We've chosen the color of white. We've chosen our fonts, and the same here, we've chosen our fonts, which are background whites and backgrounds. What is particularly interesting here is that we have the hover option, which basically will follow our mouse in the output as we scroll through it. And as far as I remember, we looked at, let me just, table styles, no, we'll be looking at limitations. Where is the index? Yeah, it doesn't work with indices, so we don't really need them. So what we can do is just hide it, index. And with any luck, AOF, did I copy something wrong? Copy, head, style, set table styles. If anybody sees the error, just let me know. Hide index. Okay, let me see if I copied that right. Let me just try again. I'm just not sure if we made a boo-boo somewhere. Nope, we didn't close something up. TH, property background, this is closed, this is closed. There's something up here. Why is it colored? Props. Select a DD. Background yellow. This is closed. This is closed. This is closed. Is this closed? This is closed. This is closed. I'm not sure what's wrong. Style set table styles. Before, after. Okay, thank you, Mateusz. Before, after. This is closed, this is closed. Okay. Do you see which line by any chance? Because I'm not sure. I'm not seeing things here. Selector, TLDR, font family. This is closed. I'm not sure here. Okay. I'll fix it in a moment. We'll get back to that because I'm not really sure. Line 17. This one closes this one. So with any th, dd, hide index. You're saying this? Oh, perfect. Thank you, Mateusz. Yeah, that's right. I didn't close this one off. Thank you. Much appreciated. So as you can see, compare this output and this output. It looks much more pleasing to the eye. By the way, I did the formatting, so don't judge me about the colors. I said I don't know about them. But I believe this is a much nicer output when it comes to the presentation of the data, because you can clearly see exactly what's happening. The formatting is nice and clear, and all the information is nicely displayed. You can also play around with the size of the font. You can play around with the font styles. You can play around with colors. It's all much to your delight in terms of how you want to go about this. Okay. What is also interesting is that we can do the we can save these files to XLSX or to HTML, and we can then export it directly into a flat file that we can then reuse. So for example, if you get any raw data that looks like the ones we saw at the beginning of the string, then you can by all means format it this way and have it nicer and present it to people that that don't really want the graphs, just want a quick output on what's going on with the data. So that's very much useful. Okay. All right. So what we'll do now is I will probably need to convert this to the numeric output, because we will need to work with it. And I'm guessing, because I've seen this once before, and I'm guessing there was we can turn the item price into the float, which we'll do now. So if we need to, step one, check the item price type. So we'll do that real quick. Type. And again, we've checked that already. We have the object. So now create a lambda function and change the type of item price. So what we'll do is we'll unfortunately call it a floater, and using the lambda expression, what we'll do is sorry, I'm looking at the chat at the same time. It's very difficult. Is create the conversion into the float type. Now, as far as you can see, if we check its head, as we can, we have this little dollar sign, so we need to get rid of it in order to turn the rest. So we need to get rid of that dollar so we can turn the rest into the float. So what that means, we need to X start from the first, or really the second item, because Python is zero indexed, and we can type it this way, or we don't need this -1 because we're going until the very end anyway. And the next thing that we do, I'll just borrow it from here. And we apply this function. Now, I had a discussion with a friend recently about why we apply things like this, because we have methods such as astype, or toNumeric, which usually goes here. Sorry, pd to numeric. And we were having a discussion why we need to particularly apply this to our series, to our column. It is because the apply works on the entire set of the values at once. So basically the concept of broadcasting comes into place here. We wouldn't be able to do that with as type because it wouldn't know what to do with the dollar, as well as it's not really applicable to the broadcasting phenomenon. So we need to do this way. So apply, and we need to confirm that we indeed converted the column correctly. So we'll do that dtype, and now we have the float 64, which is what we wanted. So scrolling back to our output and to our further tasks, what we'll do is play around with the numeric columns. And how do we play around with the numeric columns? What we do is we first and foremost and we do the numeric columns. We select the ones that we are interested in, and if we do quick info on it, we see that we have two numeric types. We have the int64 and the float64, and the float64 comes from our conversion here. So let us just choose this, and we do the numeric sub-data frame, and we'll do it using the select dtypes method. And as you can see, Shift-Tab does this little docstring information on what the function takes in terms of arguments, and you can see that we have include and exclude. So which data types we want to include from our data set, or which values we want to exclude. And we'll do we must give it, as you can see, at least one of these parameters must be supplied. So we can't really do the empty one because it cannot be empty. So what we'll do, and it takes a list, so we'll do int and float. And we'll check that it's read correctly. So we only see those three columns, the ones that we are interested in now. This one, and this one. All right, so what can we do? Let me just check. Okay. Still quite silent. What we can do about this. Excuse me. We'll play around with these by trying to see how we can show the intensity of the values as they change, as they grow in value, as they grow in number, as they grow in value, as they grow in certain kind of intensity, for us to see. Okay, so the first thing that we'll do is we will choose the gradient. Now we need an extra library for it, which is called Seaborn, and we import Seaborn as SNS. This is a standard alias that we use. It's basically by convention. There is no other reason for it, especially when it comes to the brevity of the reference. So what we'll do is we'll create a column map, and using this package, we'll do, let's say, red, and we need to specify it as CMap, right? And then applying this to our newly created data frame here, what we'll do is use the style and do the background gradient. And our CMap, so our color map, as you can see, it takes the, what's Pubu? I want to be interesting, what's Pubu? It's a very cool name. So our CMap for now will be our CMap declared here. And it's thinking, and it's thinking, and it's thinking. It'll probably be, it's probably too long of an output. We'll do the same thing at 10. Okay, you can see that this shows us exactly where the values, as they grow. So you can see that this one grows linearly up. This one is jumbled up. This one is very static with an exception of this one. So they all change differently, which is quite cool. I'll show you another method when it comes to output. Head only looks at the top 10 rows. Tail looks at the bottom 10. We have a method called sample. And as you can see now, these are all chosen randomly. So if you want to look at what's going on in the data throughout, and if you watch this, particularly here, as I do this and as I run it again and again, these numbers change. So it's chosen at random which values and which rows are looked at. I want to know what the Pubu is, so let me just Pubu. Was it Pubu? Yeah, that looks pretty nice as well. See, I'm glad there are smart people around us that do the colors, so I don't have to think about it. Okay. Okie doke. What am I thinking? You can show this to your bosses, to your managers, to whoever is interested in the data in this way. Sometimes though, we need to combine the idea of having the intensity of the values, having a graph, but also put it in within this. And we can do that also using the Pandas styles methods. So I'll show you. We'll do the sample again, just for kicks and giggles. We'll use the style, and we'll do the bar plot. And we'll choose the color, probably American, purple, purple. Right, so here we can see that the intensity of the values grows. If you turn your head 90 degrees to your right, you'll see how the bar plots are being projected, and you can see how they change throughout the data set. So if you do it several times, you see the bar plots change. So that's pretty cool. You can again export it to your HTML or XLSX or Excel files and show it. And there is a method in the documentation. And beware though that this is an experimental method still, so it may not output the way you want it 100%, but it's definitely worth trying. So I strongly recommend it. Alrighty. So we have that. Let's run it one more time, just because it looks nice. And right, okay. So that's pretty much most of the things that I wanted to show in terms of formatting. So let's just finish this this task, and I'll tell you what's going on later on. Okay. All right, so what is the number of observations? So if you have a data set, that one we saw, we don't have to really draw it because it's already there. Okay. The rows usually mean observations. The columns usually mean variables or dimensions or features, depending how you want to phrase it and depending on the context. So if you want to check the observations, we can do it in two ways. We can check the length of the data set, which is 4622. Or we can do the shape function, which shows you both the number of observations and the numbers of features. But because it's a tuple, we can index into it and just show us the numbers of rows. Okay. Number of columns, again, using this shape function or method, we can index in the second element of it and get the number of columns. Now a quick note on the print function. Let me show you. We need to see all the columns, the names of all the columns, which is quite nice. We have order ID, quantity, item name, blah, blah, blah. What happens if I print it 5 times? You see the output looks pretty jumbled up and very hard to read. Now imagine if you were working with text data and these are all outputs of a different, tweets about something, about a company, about in terms of opinions, airlines and so on and so forth. It would be very hard to read. Thankfully, Bash, of all things, so the Linux scripting language, comes to us with help. Take a look at this. What I'm going to do is do the following. Print, and now 033, which is our escape character, 31, 1, 1, just 1, okay, 4, hello, again, escape character, close this, and we're exiting out of the formatting. And you can see, let me just make it bigger. The hello is formatted, underlined, turned into red, and it looks very, very different and much nicer. And what I mean by much nicer is we can play around with this output as well. So again, just for the just for your pleasure and my lack of willingness to type, I've prepared a list of colors that I found online. That we can use, and you can see all of them start with 033 /033 to mean we're entering formatting mode and we're starting with a escape character. So how we can play around with this? First and foremost, let's define a function that will use these colors for us to choose when it comes to the output and what color the output will be. So we're going to call it print with color. And we're going to have two things. We're going to have what the message is, which is basically what the text is, and the color that we want to use. And it will print from our dictionary here. It will print, what will it print? Using the get method, which I'll explain in a moment, color, lower, and then color, default. So what's happened here, real quick? The get method, let me just close it before I forget so that my toes doesn't have to chase me again. It will take the color from the dictionary if it exists. If it doesn't exist, it will default to default, which ironically is what is happening. And print it in the color that is defined as default, which is in our case 99. And then we'll take our message as well, and we'll probably need to close this. Yep. So let me delete this because we don't need it anymore. And now look, df columns. Not df, cheaper. Yeah. And now we'll do print with color. Print with color. Oh yes, we need the. We need this. So let's say yellow. You see, the output is different, and it definitely looks much nicer. And you can, but more importantly, it differentiates between the output here and the output here. So let's try and use it throughout our output. So we'll do a small for loop. Color keys, which is this side here, and we'll do print with color, df columns, and then key, following the get function, right? Again. You can see that this text is now much easier to read and much easier to differentiate where one ends and the other begins. So definitely worth looking into and playing around, especially if you're dealing with text data. Okay. So how is the data set indexed? So we'll just look at the index, and it's indexed from 0 to n-1, which is 4622, 462, it gives you the last value and step of 1, which basically is 0, 1, 2, 3, and so on. Okay, we've kind of done this already, so we don't have to do it again. Now, let me check the chat real quick. Okay, so we'll call it most ordered item, which basically a most ordered item, and we'll do a small group by. Group by is a function that lets you, by definition, group things by a certain column. So we'll group it by item name, and we'll do quantity. I'm missing here. And then sum up the observations. And you'll see by each item name how many times was it ordered. So now, I'll show you 2 ways actually. First one is just sort values. And then we'll do ascending false. And then first observation, because that will be the highest. And we have the answer, 761 chicken bowl. But considering the limitations that we saw, that it only works in with data frames, we can cast it to a data frame. And you'll see something funny, because we've kind of dealt with the quantity over here. But if we do head style highlight maps, it doesn't take the group by element, because it's cut out because it's a series, and it's quite interesting to see how we lose information as a result of it. So we need to do explicitly by quantity, and then we'll get our maximum value highlighted. Okay. Let me check if there are any questions. Still nothing. All right, moving on. So let's have a look at how we can deal with the next question. Well, the next question is kind of answered, because how many items were ordered? They're already here, so we already know that. So basically see above. And we're done with this particular task. In the item choice description, we'll have to do the same thing. So basically, what we'll do is group by, and we have to use choice description, and sum it. And let's assign it to something, because we'll do further operations. We'll do sort values again. So basically we're following the same logic as we did before with the most ordered item here. So the same logic, sort by quantity. And then again, ascending false, so descending true. And then check the first observation. And we have the Diet Coke of quantity 159. You see? How many items were ordered in total? All right. So basically, to check that, we need to look into the quantities of each of the items that were ordered. So we'll do quickly quantity. And sum it up, and we see that the total the total quantity of all the items ordered is 4,972. Okay, so now we're dealing with the revenue. Let me check again. When it comes to this, okay, so we'll do revenue. And the revenue is basically the quantity multiplied by the item price and summed up together. So that's what we'll do. Quantity times item price that we've converted to our float earlier, so now we can use it as a number, and then do the sum and output this, and we see that's 39,237.02. It was the total revenue. Now, how many orders? So orders we'll do by order ID, and we can do it in two ways: value counts and then count, because value counts just tells us, as we saw before, how many of each, and you can see the output is cut off. So we want the total number. We can't sum it because it doesn't make sense here, but we can count all of the elements, and we have 1834. But if you look at orders 2, just to compare, we'll take this and do n unique, and we'll do orders 2. We'll get exactly the same number. So this is equivalent to this, and this is the number of unique values that is in there. Okay? And the average value, I'm checking the chat every once in a while. Sorry. What am I doing? Okay. And we'll do here. No chat. No nothing. Okay. So let's do these two challenges together and we'll be done. So the average revenue. So we'll add basically this here, but without the sum, because we need elements of this. Quantity times the item price. Yeah. We'll group them. And we'll do order already, because we basically want the unique values of it. Sum. And then we'll need the average value, so basically the mean value of it. And then we can select the particular column that we want. So we can index into this as well. And if we're very pedantic, we can round it. Round to 2 decimal values, and we get our average price, or average revenue, sorry. Okay, and then, excuse me, how many items, so item name, and again, we can use either this or that, and it will give us the right and unique, and we forgot this. And we have 50 different items that were sold. So with this, we've completed the first challenge of many that are in the GitHub repository that offers these EDA exercises. Next time we'll go through the all the others. We won't be doing so much styling and so much coloring. This what I thought was just a nice addition today to the stream overall and what you can do. But we won't be wasting time from on doing this in favor of actually covering more content in terms of the challenges and how we can approach them. So we'll try to do more of these next time. So what we've covered today is basically the styles of pandas. You can find the documentation, and I'll probably add it to the description if need be. And I'll also upload this to our GitLab, and the GitLab is probably in our description already. So again, we've looked at some EDA techniques and methods to help us discover the information from the data. And we'll continue that next time. So again, shout out to my first Patreon. I'm very, very grateful for this. If you have any comments or questions about what you would like to cover next as well, let me know in the comments. And I don't know what you say, like subscribe and hit that like button, smash that button. What was this saying? I don't know. I'm not a streamer, just starting. So, and let me know if you have any questions or ideas for what we can cover and how we can diverge the Polish and English streams in the future. So thank you very much and see you next time. Let me just check the chat real quick. All right, so thank you very much and